Okay, today we're going to be starting 1.2 matrices, continued on with determinants and inverses. I just want to start with some notation differences. When we talk about a matrix, it is in brackets here. We're talking about a determinant. It's just two bars, kind of looking like an absolute value sign. We're looking here, D is saying here is a determinant, this is a 2 by 2, and we're going to take the determinant by first multiplying on the diagonal this way, so we would say A times D, subtracting around, coming the other way, and multiplying these two numbers together, B times C. So let's look at example 1 here. First we're going to multiply on the diagonal going this way. And we'll get -4. Remember, this is a subtraction coming around and flipping down the other way here. We get +10. So the determinant here would be -14. Just another quick example. Going this way first, we have -24. Remember, it is a subtraction as we come around. -8 times 3 is also -24. Obviously, the two negatives together become a positive, and our determinant here is 0. Alright, so those will have to be done by hand. We're also going to do the 3 by 3 by hand as well. So the first thing you want to do when finding the determinant here is first take these first two columns here, and we're going to repeat them over on this side. So just 2, 4, 3, -1, 1, -4. So first you just want to repeat those columns as you see them. And we are going to, let's see here. First thing we're going to do, I'm going to put this in yellow, we're going to multiply on the diagonals, starting with this first number here, multiplying all these numbers together. So that is going to get us -4, so let's group these guys together. I'm going to do the next diagonal going this way here, and that's going to get us 0. And then the next diagonal is right over here, multiplying those numbers together, and we get 48. We're going to subtract, coming in the other direction, multiplying, starting with this first number here, going this way, and that would get us 8. Then we're going to do the next diagonal over here, also getting us 0. And then the third one over here, getting us -9. Now we can just combine up all our numbers here. We have 44 minus -1. So the determinant here would be 45. Okay, so we're going to do the same thing here. I could see that the determinant's equal to 4x, but first I got to figure out kind of what that determinant's going to look like. So I'm just going to move this down just a little bit. Okay, so I'm going to rewrite this whole thing here. So we have x1, 0, 1, x1, 2, 3, 2. I'm going to repeat the first two columns just like I said before. Alright, so we're going to start multiplying on the diagonals coming in the other direction. So first we're going to start going this way here, and that's going to get me 2x squared. Moving to the next one over here, we're going to get 0. And the next diagonal over here would get us 2. Subtracting, coming in the other direction. We're going to multiply these guys here, and that's going to get us 2. Moving to the next one over here, we get +3x. And the next diagonal over here gets us 0. That is the determinant, but I do know that it is equal to -4x. Let's just start combining up here. We have 2x squared plus 2 minus 2 minus 3x, and I'm going to subtract this -4x over to the other side as well. The 2's will cancel, and we're left with, let's see here, 2x squared 2x squared, oh, this would be a plus for x, that's why I was getting a little confused, plus x is equal to 0. Had a little boo-boo there. Let's take the x out. 2x plus 1 is equal to 0. So we get x is equal to 0, and x is also equal to negative 1/2. Okay, we can also find determinants using our TI-84. The directions are here. I'm not going to pull the calculator out. That is certainly something you can do on your own. If you're having problems with that, just go ahead and ask your teacher exactly what to do with the calculator. We will be showing you guys in class. So again, this was just calculator work. If you want to try that, you should be getting 45 here and also negative 206. As far as testing goes, we do expect this to see the work. You do need to know how to take the determinant and show all this work for a 3x3, but we are allowing you to check with the calculator. Alright, let's flip the pages over and continue on. First thing I'm going to talk about is what is an identity matrix, and that's when the main diagonal in the matrix all the elements are 1s. Okay. All other elements are 0. Okay. So the identity matrix for a 1x1 would just be a 1. The identity matrix for a 2x2, the 1s are going down the main diagonal, everything else is 0. An identity matrix for a 3x3, again we have 1s running down the main diagonals and then 0s sitting everywhere else. Alright, so let's talk about inverses of a matrix. An inverse will exist if I can multiply the original matrix by its inverse and we get the identity matrix. That's why we were speaking about these identity matrices here. Alright, so first thing we need to do is how do we find the determinant, the inverse of a matrix. And we're going to just start with these square matrices here. The formula for this is, if this is our original matrix with A, B, C, and D, it's going to be 1 over the determinant. Remember, the determinant is shown with those straight lines. On this diagonal going this way, you're going to switch. So we had A and D, and now we can see we have D and A. The diagonal going this way, we're going to negate. So here both C and B were positive, now they are negative. So in order to find the inverse, the first thing I need to do is find the determinant. So the determinant for this matrix, remember we're multiplying going this way, is negative 10. Subtracting as we come around, we get negative 9. So the determinant for this particular matrix is negative 1. So I know I'm going to have 1 over negative 1. And when we want to find the inverse, we're going to switch the diagonals going this way. So negative 1 and 10. I'm going to negate going in the other direction. And then we're just going to go ahead and multiply in there. So our inverse, I can't spell, inverse matrix here is going to be 1, negative 3, 3, and negative 10. If you want to check, and we may be asking you to do that to prove to us that that is actually the inverse, if you multiply the original matrix, which was 10, negative 3, 3, negative 1, to the inverse, which we have 1, negative 3, 3, negative 10, and again, remember, we learned how to multiply these matrices. I'm going to have a workbox, and then here's going to be my answer. We should wind up with the identity. So here, we're looking at row 1, column 1. So I'm going to pull from row 1 and column 1. Here we get 10, negative 9. That does get us the 1. This spot here, row 1, column 2, pulling from row 1 and column 2. So row 1 and column 2, we get, let's see here, negative, row 1, column 2. Yes, so we have negative 30. Over here we have positive 30, and that comes out to be 0. Over here, row 2, column 1. So I'm pulling from row 2, column 1. Here we get 3 and negative 3. That does get us the 0. And then lastly here, row 2, column 2, we get negative 9 plus 10. And that gets us a 1. And that's how I prove to myself that I actually do have the actual inverse. So here's a thinking question for you. Taking a look at the formula over here. So we're right here. How or when will a matrix not have an inverse? And it comes from here, this part here. In any fraction, the denominator cannot go to 0. So the answer is here is if the determinant is 0. Alrighty, so just noting, just to prove that a matrix has no inverse, you would take the determinant and see if it is 0 or not. Inverses and determinants can also be found on the calculator. Again, this is just directions on how to do that on the TI-84. I will not be doing that on this video. If you do want to give it a try, the answers here should be negative 3 over 10, negative 1/5, 3 over 10, 9 over 10, 3 over 5, 1 over 10, negative 1/5, 1/5, and 1/5. When you do this on the calculator, it is going to give you decimals to begin with. Just go ahead and change those guys to fractions. If you're just doing this for more practice, the answer here when putting this into the calculator would be 1, 1, negative 2, negative 2, 0, 3, 3, 1, 0. Alright, and with that, that concludes our lesson on determinants and inverses.